Alrighty, so we are talking about shapes as our next thing. So the thing to keep in mind is it's actually not, they tend to be nicer at level 3 than they were at level 2, in that the questions that you draw the Lewis structures and identify the shapes with aren't often tied to then your justification question. So the way this question is normally structured is you have Lewis structures that you're supposed to be drawing and then naming the shape of them. And then you have a second section of the question, and that question asks you, okay, we've given you the shape, we've given you the Lewis structure diagram. They probably will give you two because I love comparison. So they'll actually give you the answer and they'll just ask you, okay, how do you know it has this shape and how do you know it has this polarity? So this question's very intertwined between shape and polarity. So just keep that in mind. With the write-up, they basically smash it into one question instead of having it as two separate questions. So the good news is you don't have that same high stakes as last year, that if you make the Lewis structure wrong, you get the shape wrong, and then you try to do your justifications, it's all snowballing. So that's something to kind of keep in mind. The same rules apply that we talked about last year. So the thing about VSEPR is the big thing. So that is the repulsion theory that we've talked about. So regardless of if you have bonded or unbonded electrons, they still are regions of electron density, and they're going to separate to maximize the distance apart to minimize the repulsion. I'll write this on this piece of paper here just to remind us that, VSEPR is the reason why we're seeing all these shapes arise. VSE, VESP. I think that's how it's spelled. It is an acronym for something. It was like valence, shell. I looked it up the other day. You don't actually have to explain the acronym, but you just have to know what it means. And it's basically we are trying to separate the regions of electron density to maximize the distance apart, to minimize repulsion. Maximize distance. Yeah, what's up? Oh, yeah. All right. Yeah, I'll see what happens after I mark your stuff too. Okay, so we want to maximize distance because, they're all negative charge regions. Hey. To minimize repulsion. So I'm writing that down. I'll scan it just so you guys have that as well. So just as a nice little reminder. So whenever we're looking at our shapes for our molecules, we're basically going through and we're trying to count how many regions of electron density I have, because that's going to first influence how everything's going to separate into its various bond angles. Something that was really important to last year's answer was understanding why certain things have certain bond angles. So how could you, for example, have a bent and a bent? There's two bents here, but they have different bond angles. Not a huge fan about how. I mean, yes, that is the more correct number, but you probably have used to seeing them as 120 and 109.5. But they won't split hairs if you write slightly different numbers down, because, in fact, this is actually the better answer because lone pairs of electrons have more negativity than bonded pairs of electrons, so it does actually make a difference. But in the end of the day, if you just want to memorize the 120, then it's fine. So you guys saw that a lot. How can you have the same shape but different bond angles? And that has to do with the number of regions of electron density. That is still potentially to come up, but probably not to that same extreme. The other thing that won't be coming up to the same extreme is, can you state the bond angles? Because when you guys are looking at these larger molecules, not only do they have more bond angles, but because of the shapes, you can have two different bond angles as well. So that's unlikely. I have not seen that come up in an exam or even a mock exam, expecting you to know that, because that is a lot of, I think, useless memorization. So that's something to keep in mind with that. So last year you were thinking about, okay, how many regions do I have? How's it going to affect the angle? And the next question then is how many things are bonded and how many things are unbonded? Because we have to remember that when it comes to the shape, the things that are atoms that are actually bonded, that is going to show up as the final drawing shape, because the electrons, the lone pairs of electrons, are not drawn in the final shape. They affect it, but they're not drawn in it. And so that's something to keep in mind. And that's something that you'll notice if you play with the PhET program that's on lesson number 4. You can tick various boxes and you can take, there was some like geometric shape and electron density shape or something like that. And then also bond angle as well. So it does actually go through all those things. So that's the first thing to think about when you're doing the justification is half the question's asking, why do you have this shape? Second half of the question is, why do we have this polarity? So that's something to keep in mind. So I haven't given you guys any exam questions tied to this lesson yet because it's so tied in with polarity now this year that I didn't want to start it because you're basically just doing half of it. But the main thing to think about is how things are going to be organized. And I really, really, really like this setup because it first has you think about, okay, how many regions of electron density do I have first? And then I ask bonded or non-bonded to then figure out my shape. So the ones on the top are all the ones that we've done last year. They were pretty logical from what they had shape-wise. Triagonal meaning 3, planar meaning flat, pyramid being 3D pyramid. Bent looks like bent, linear looks like linear, and tetrahedral means 4. Tetra's 4. So that's all stuff. Very unlikely they'll ask you those molecules because they're going to look at the larger ones. So 5 and 6. One of the things that we talked about in the notes for the previous lesson is that because we're now dealing with larger molecules and larger atoms, we now have a vacant D shell or D subshell that then allows what's the word I'm looking for? It allows for us to extend the octet. So we've previously been talking about 888 as being the magic number. In reality, there's actually space in the atom to have more electrons, and that's the extended octet. So that's why we're now able to make things that have more than 8 things attached to it. I'm just going to pause it because I can see heads popping out. All right, cool. So 5 and 6 region. So that's why we're able to do that extended octet. We now have more space because of that D orbital. Cool. What else do I want to talk about? So shape-wise, again, it's just a lot of memorization. Some of them look like they were supposed to, and they make kind of sense. So bear with me. The linear shape, obviously linear, because it's straight line and it has lone pairs of electrons around it. So there's only 2 other things bonded to it. So that's why that's linear. The T shape is a T shape because it looks like a T. Okay. So again, we're just counting the number of regions. So that has 2 lone pairs, 3 bonded, thus the T shape. Seesaw, I also have seen called horse saw or like rocking horse or something. I think it's supposed to look like a rocking horse. So when you turn it on its side or something, it's supposed to look like it's like a teeter tot.
Oh, yeah, I see.
Yes. So tough. And then you have the triagonal bipyramid. So it's like the same thing as the triangle pyramid, but it's both top and bottom. Yeah, see, it's logical. Logical. Then the 6 regions. You have the square planar, which is planar means flat, square means 4, so that looks like a square. Yeah. Okay. The square pyramid has the 4 bottom. So it's like a pyramid, but instead of having only this the triangle bit, you have a square going up to the triangle. So that's that one. And then octahedral is the last one, which I don't actually have a good way to remember that one. I think it's because it has 8 sides is probably where that came from. I think geometrically it's probably 8, so that's where octahedral comes from. That's all the new shapes. Okay. They will, I would say, like, I'm 99% sure they're going to ask you a question on these guys and not bother with these guys. So be ready to learn the new guys. All right. Flashcards, they will not give you this on the assessment, so you do need to have these memorized. But they're kind of logical. So just like last year, it was kind of logical. All right. Cool. The other thing that I said to Serena that I want to make sure you guys get passed on with the SciPad pages, they do have an extra section looking at the electron configuration as part of understanding the Lewis structures and the shapes. It is good to know conceptually, but it is not actually part of the assessment. So when you have your essay write-ups, they're not actually going to ask you to do that. So it's just something extra the SciPad has done. So don't stress about that. The reason why they're doing that is just to show you that there isn't a vacant D shell that things are going into. That's all. Okay, cool. That's it.